Hi, it's Barb, Meeple PhD, coming to you with another Cosmic Game Connection. This time I saw a news feature about a galaxy collision that helped form our own Milky Way galaxy ages ago. Large galaxies, like our Milky Way, form through a series of mergers. But one big question is, does it happen in a series of small mergers or just a few large mergers? Astronomers found one piece of this puzzle using data from the European Space Agency's Gaia mission. Gaia has been charged with precisely measuring the position and velocity of over 1 billion stars in the Milky Way. Using one of the recent data releases from Gaia, these astronomers found a population of stars that weren't moving exactly the way they should if they had been born alongside the other stars in the Milky Way. They took it a step further, though. They also looked to see the chemical composition of these stars. That is, the different elements that they were made of and the different proportions of those elements in those stars. And they weren't consistent with having formed in the Milky Way. The evidence points to there being a dwarf galaxy that the researchers have called Gaia Enceladus that collided with our own Milky Way 10 billion years ago, before our sun was even a star. The other thing they've been able to figure out is that that dwarf galaxy was probably about the size of the Small Magellanic Cloud. That's one of our nearest neighbor galaxies today and has about 1/10 the mass of our own Milky Way. But at the time of the collision, the Milky Way was a lot smaller and was only a few times bigger than Gaia Enceladus. Such a collision would have had a major impact on the Milky Way, helping to form some of the features we see in it today. It's exciting to me to see how did our galaxy form, and seeing these pieces come together and that you can say, look, there are some stars that don't belong here. They came along 10 billion years ago. This study and others from Gaia will help unravel that formation history of our home galaxy. When I thought about these stars embedded in our galaxy from an early collision, the game that came to mind was Small World. In Small World, players control a series of fantasy races with special powers in an effort to conquer and take over territories in a mythic land. The game is played in a number of rounds, which depends on the number of players. Each player starts by choosing a race and a special ability from the ones available on the board, and taking the number of race tokens indicated by the combination of the two. Then they start conquering the board, using 2 race tokens for every territory, plus an additional token for anything already on the board, something like a mountain or a lost tribe, or even your opponent's tokens. At the end of their turn, players get a piece of gold for each territory that they occupy, plus any bonuses that might come from their race or special ability. The goal is to accumulate the most gold by the end of the game. At some point, the player will decide that that race has gone about as far as it can go. Maybe it's been conquered by others, or it's spread too thin across the board. At that time, they can spend a turn putting that race into decline. This consists of leaving 1 token in each territory on the board that that race currently controls, but turning it upside down to indicate that they are in decline. Other players can continue to conquer those in decline races, but the current player can't continue to conquer with those races. On their next turn, the player chooses a new race and begins to conquer the board yet again. Eventually, the board is dotted with these in-decline races, evidence of past conquerors moving throughout the land. And it's those in-decline races that reminded me of these relic stars that we found from this previous collision with the Milky Way. In your next game of Small World, take a look around the board and notice that seemingly random pattern of in-decline races. And think about how the Milky Way experienced that collision with Gaia Enceladus, which left behind its own relics that we're just starting to find today. Thanks for joining me. I'll be back again with another Cosmic Game Connection. In the meantime, you can follow me on Instagram, Twitter, and Facebook as @MeeplePhD, and you can follow me on my blog at meeplephd.com. 1/10 the size of the current Milky Way.